What's up, scholars? Today we're talking about polynomial division. Polynomial division. So before, recall, last time we talked about multiplication. Right? We talked about going from, if I have a function that is written out as its factors, I can multiply and get it into standard form, which in this case would be x squared plus x minus 6. So today we're going to go backwards from standard form into some factored form, because oftentimes we're really interested in the factors. So being able to find those factors using some division, very helpful. Go right into a delta math question. It says, what is the result when, I'm just writing this out, 16x cubed plus 28x squared plus 22x plus 15 is divided by 4x plus 5. All right, now let's go back to our paper and solve this question. So here we are. I wrote it out like division because it is division. 16x cubed plus 28x squared plus 22x plus 15 divided by 4x plus 5. We're going to do this a lot like you used to do long division when you were in like 3rd grade. But we're only going to focus on the first term here going into each of these terms. And then we'll get the remainder for this guy. But we're going to focus on this first term. Focusing on this first term. How does 4x go into each of these? And we'll figure out the remainder to go with that. So stick with me here. If I took 16x cubed and divided it by 4x, what would I get? Well, 16 divided by 4 is 4. X cubed divided by x is x squared. Okay, not so bad. Now, just like in long division, olden days with the numbers, you multiply this back out and put it under here. So we're going to multiply 4x squared by 4x, and we get 16x cubed, which that was what was supposed to happen. And then we're also going to multiply 4x squared times this 5 now. 4x squared times 5 is 20x squared. So that's plus 20x squared. So what do? We took the first term and divided it into this first term. Got our answer, and then we're multiplying back out. So now we're at here, and we're going to subtract. Just like we did in long division way long ago. 16x cubed minus 16x cubed, that should cancel out. That was how we set it up that way, so that should happen. 28x squared, remember this is minus 20x squared, that's going to be 8x squared. Okay. Now we're going to bring down this second term and repeat the process. So 4x goes into 8x squared how many times? Well, 8 divided by 4 is 2, and x squared divided by x is x. Okay, great. What did we do before? When we got that, we multiplied. So now we have this. We're going to multiply again. 2x times 4x is 8x squared. And 2x times 5 is 10x. Awesome. Now, let's subtract. These should cancel if we did this correctly, which we did. Of course we did. And we get 22x minus 10x is going to be 12x. Great. Bring down the second term. So we've got 2 to work with. Why do we need 2 to work with? Because we've got 2 in our little part here, what we're actually dividing by. So let's lather, rinse, repeat. Where are we at? We've got this 12x. What am I supposed to do? Oh, I'm supposed to divide it by 4x. 12x divided by 4x. Well, 12 divided by 4 is 3. And x divided by x, that's just 1. So I don't have any x here anymore. So that's it. 12x divided by 4x is just plain old 3. That's what it is. Now let's multiply this back out. 3 times 4x, I knew what the answer was, is 12x, and 3 times 5 is going to be 15, and now we subtract 12x minus 12x, that should cancel, and then 15 minus 15, that cancels too, so we have a remainder in this one of 0. Awesome. So our final answer when we divide this long polynomial by this binomial is 4x squared plus 2x plus 3. There's no remainder in this case. X squared plus 2x plus 3. Submit. Are you sure? Yes, I am. And you're sure as well. Oh, we did it! So this whole thing here is called long division. Long division. If you like long division for dividing polynomials, that is awesome. Here it is. This is long division. I'm going to show you another way to divide polynomials called synthetic division. Let's go right into our Delta Math question. It says, what is the result when 3x to the 4th minus 5x cubed plus 7x squared plus 3x minus 8 is divided by x minus 1? Well, this looks like a very similar question, but it says synthetic division. You could actually solve this using long division like we just did. If you love long division, that's your tool, man. You use it. But I'm going to show you another one called synthetic division, which will also give you an answer. So again, synthetic division, just another way to divide polynomials. It is simpler to do. It just makes less sense because you can't see all of the work. But let's just stick with me here. Follow along. We're going to take this divisor and set it equal to 0 and solve. X minus 1 equals 0. Easy peasy lemon squeezy. We get x equals 1. X equals 1. So that number is going to go into the box. I should say synthetic division, this shortcut way of dividing instead of doing long division, only works if the number in front of the x is 1. Okay, that really must be a 1. If it's not, there are some things we can do to make that happen, but in this case it is 1, so we don't have to worry about it. But this must be 1. Must be 1. Alright, so first thing you do, take your divisor, set it equal to 0, and solve and put that number in the box. Then you're going to bring down all of the coefficients, making sure you have a coefficient for each term. We have one for x to the 4th, x to the 3rd, x squared, x, and the constant. So in this case, we have all of them. If we didn't have one, let's say we didn't have an x squared term, we would put in a 0 for that. But we do have an x squared term. It's 7. So we'll bring down all these numbers. 3, -5, 7, 3, and -8. All right, great. So the idea behind this, our line, we're going to add straight down and then multiply by the number in the box. Add straight down, multiply by the number in the box. What are you saying, Miss Akin? What's happening? Just watch, just watch. So we're going to add straight down. Add to what? There's nothing here. You're right, we're adding nothing. So 3 plus nothing is 3. You could think of that also as copying the first number down or bringing the first number down. But you could think of it as adding straight down because that's what we're going to do with all of the rest of these. Add straight down, then multiply by the number in the box. 3 times 1 is 3. Cool. Add straight down, we get -2. Multiply by the number in the box, we get -2. Add straight down, we get 5. Multiply by the number in the box, we get 5. Add straight down, we get 8. Multiply by the number in the box, we get 8. Add straight down, we get 0. Okay. What does this mean? Well, this very last term is our remainder. This term, so in this case our remainder is 0, which meant this divided perfectly into this polynomial. Pretty cool. That last term will always be the remainder. The next term is then going to be the constant, and then we'll go up as far as this will be the x, this will be x squared, and this will be x cubed. So our final answer, 3x squared minus 3x cubed minus 2x squared plus 5x plus 8. This is our answer. Let's go plug it in and get that satisfying check. 3x cubed minus 2x squared plus 5x plus 8. Submit our answer. Are you sure? Yes. Yes, I'm very sure. Are you sure is the question. I think so. Ta-da! Very good, very good. Right, so far when we've done these questions, we've had remainders of 0. And that's pleasant, but we know that that doesn't always happen. Does not always happen. Sometimes we have remainders, and they're valid, and they deserve their due. So let's go check out a situation where we have a remainder. Alright, this guy says, what's the result when x to the 4th minus 3x cubed plus 14x squared minus x plus 19 is divided by x plus 1? If there's a remainder, express it in the form q of x plus r of x over b of x. What? What is that? Oh, don't worry. I'll show you. Alright, so let's set it up. What do we do first? Set this equal to 0 and solve. When we do that, we get x equals -1. That's the number that goes in the box. We bring down the coefficients for everything, making sure we have a coefficient for each term. Well, I have an x to the 4th and a 3rd and a squared and a linear term and a constant, so I have everything, so I don't have to put in zeros. Again, if I was missing something, like if I had no x term, I'd have to put a 0 in for my coefficients on this line, but I have an x term, so I don't have to do that. So coefficient here, that's just a 1, and a -3, and a -14, and a -1, and a 19. Great. Add straight down. 1 plus 0 is 1. 1 times -1 is -1. Add straight down, we get -4. -4 times -1 is +4. Add straight down, we get -10. -10 times -1 is +10. Add straight down, we get 9. Multiply by -1, we get -9. Add straight down, we get 10. That was super fast. Super fast. Now, what does this mean? This last number is always the remainder. That's the constant. Ignore my animals back there. That's our x squared, and that's our x cubed. So, we're writing out our answer here. We're going to have x cubed minus 4x squared minus 10x plus 9 plus our remainder over the thing we were dividing by. What were we dividing by? Way at the very beginning. We were dividing by x plus 1. So this is our garbly-gooked answer, right? It said something about was q of x plus r of x over b of x. So that q of x is our quotient. That was our answer. That r of x is our remainder over our divisor. Great. X cubed minus 4x squared minus 10x plus 9 plus 10 over x plus 1. X cubed minus 4x squared minus 10x plus 9 plus 10 over x plus 1. Submit it. Are you sure? I'm always sure because I check my work like a bunch. Okay, so the last thing we're going to talk about is using synthetic division to find the zeros. Finding zeros means finding roots, means finding x-intercepts. So when we're done, our answer should be x equals some number, and some number, and some number, and so on. We're going to find the places where the function crosses the x-axis using synthetic division. Let's go get a problem from Delta Math. Alright, so this says if f of x equals x cubed minus 5x squared minus 8x plus 12, So that's our polynomial. And it says x minus 1 is a factor, meaning it will divide perfectly into that polynomial. We will have a remainder of 0. Then find all of the other zeros algebraically. Let's write this down and take a look. All right, so I just wrote it down. X cubed minus 5x squared minus 8x plus 12 divided by x minus 1. I can use synthetic division because the coefficient on this x is 1. I don't have to do anything to it. We're going to stick in that realm for today. It says that this should be a factor, so when I divide this, I should get a remainder of 0. Let's just double check. Let's just make sure there's nothing funny going on here. Set this equals 0 and solve. We're going to get x equals 1. That's the number that goes in the box. Bring down the coefficients. I have all the terms. I don't need any zeros. So 1, negative 5, negative 8, and 12. Solve. 1 plus nothing is 1. 1 times 1 is 1. Add that together, we get negative 4 times 1 is negative 4. Add that together, we get negative 12 times 1 is negative 12. Add that together, we get a 0. All right, so they weren't lying. There's no remainder. This is actually a factor. So this is the constant. Let me just write that down. Remainder. This is the constant. This is the x term. This is the x squared term. For paper, we'll slide this up. Great. So we now have x squared minus 4x minus 12. And we're supposed to be finding the zeros, right? We're supposed to be finding the zeros, which means we're going to factor this dude. We're going to factor this. So we could use our ACB tree to factor this, right? A times C, blah, blah, blah. Let's add up to equal B. A times C, 1 times negative 12 is negative 12. Adds up to B. B should be negative 4, which two numbers multiply to negative 12 and add to negative 4. You are correct. It is, in fact, negative 6 and 2. So we know since our A is 1 here, we can go right into our factors are going to be x minus 6 and x plus 2. X minus 6 and x plus 2. All right, so those are the factors from this remainder piece. But we're supposed to be finding the zeros. So we got to set each of these equals 0. So we get x equals positive 6 from here, x equals negative 2 from here, and originally we were dividing by x minus 1, if you recall, x minus 1, so we need to set that equal to 0 too, but we already did that. We got x equals 1. So we have x equals 1 from that original one. X equals 1, x equals negative 2, x equals 6. We should put these in order from least to greatest, so our solutions are going to be negative 2 to 1 to 6. All right, let's get that big money. 216, submit our answer. Are you sure? Again, I'm always sure. I'm always sure. And delta math is 2. Okay, recap. What did we do? We did polynomial division. First, we started off with long division. Long division, where we're writing down all this stuff, which is cool. It works. It's great. But there's a lot of writing that needs to happen. Again, if you like long division, you can always use long division. You don't ever have to use synthetic division. I, however, love synthetic division. It's so fast, it's so easy, it's beautiful, very wonderful, excellent, excellent. That's what we did. And then we used synthetic division to find, actually let me back up real quick. So we have places where we'll have remainders, right? So we don't always have a remainder of 0. When we don't have a remainder of 0, we have to put the remainder over the thing we were dividing by. That's where that came from. So we have some answer, our quotient, plus the remainder over our original divisor. Got it? And then we can use synthetic division to find zeros. So this is a factor if it has a remainder of 0. And then we factored out that last little bit using our ACB tree, set all of these things equal to 0, including our original divisor, and then put them in order from least to greatest so that we could submit to the Delta Math and get all of our points. Nicely done, scholars. That is a polynomial division, Indianapolis Classical School style. I love you so much, and I will see you next time. Keep on that hustle.